Hello students, the topic is minimum cost spanning tree. In this problem, we will discuss a very simple and common example. As we are given a graph over here, unweighted graph, you can see the edges are not weighted over here, the edges are not having some weight. So this is an unweighted graph. So the question arises here is, what is a graph? A graph is represented by vertices into edges, right? So in this example, how many vertices we are having? 1, 2, 3, 4, 5, 6. We are having 6 vertices over here. And how many edges we are having over here? The subset of the edges is 1 to 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 1. So these are the subsets for the edges. Spanning tree. What is a spanning tree? Spanning tree is the subgraph of the graph. See, here we are having a graph, an unweighted graph. So spanning tree is the subgraph of this graph. So how can we draw the spanning tree? Remember, the spanning tree will be drawn always using the subsets of the graph. So whether we should take the subset of the vertices or edges? No, we will take the subsets of edges in order to draw the spanning tree. So how many edges we will be having in our spanning tree? What is the approach for that? What is the formula for that? See, in this graph we are having 6 vertices. So in order to calculate the edges of our spanning tree, we will always use this formula. Vertices minus 1 is equal to the edges of spanning tree. So in this graph we are having 6 vertices. So 6 vertices minus 1 is equal to 5. So we will have 5 edges in our spanning tree. Let us draw the spanning tree for this graph. So we will get the spanning tree like this. We haven't joined the 4 to 5. What is the reason behind that? See, here in the graph we can have the cycle, but in the spanning tree we cannot have a cycle. If I join 4 with 5, it will make a cycle. So this will not be a spanning tree anymore. This will become a graph. This will not be a subgraph of the graph if there is a cycle over here. See, can we have more spanning trees for this graph? Yes, we can have. If I join 4 with 5, then I won't join 5 to 6. If I join 6 with 1, I won't join 2 with 3. So the choice of the edges depends on you, how you join them. But remember one thing, in the spanning tree, you should not make the cycle. Let's see. We are having another example of the graph, but the difference here is that this graph is weighted graph. Here the edges are having some costs. So how can we draw the spanning tree for this graph, the weighted graph? So let us draw all the possible spanning trees for this graph. We will get the spanning trees like this, right? Here we have drawn all the possible spanning trees for this, and we haven't joined 1 to 4 in the first spanning tree, because if we join 1 to 4, this will create a cycle in the spanning tree, and this spanning tree will not be a spanning tree anymore. This will become a graph. In the second spanning tree, we haven't joined the 1 to 2 because it's a spanning tree, and in the spanning tree we cannot have a cycle. Similarly, in the third spanning tree, we haven't created a cycle, but here the edges are having some weight, so we can calculate the cost of every spanning tree. We will just, how to calculate the cost of spanning tree? We will just add all the weights of the edges and we will get the cost of every spanning tree. So for the first spanning tree, we are having the cost 14, for the second cost 13, and for the third spanning tree we are having the cost 9. So this is the minimum cost spanning tree. The third spanning tree is the minimum cost spanning tree. So how can we calculate the minimum cost spanning tree? Yes, this is very important question. If you are given a weighted graph in the question, so then how to solve this problem? You have to draw all the possible spanning trees and calculate their cost. This is the one way. So, but the question arises here is, but this will be a very lengthy process. It will take a lot of time and it will create the time complexity over here. So is there any greedy approach to find the minimum cost spanning tree? Yes, there is a greedy method. The first method is Prim's algorithm and the second method is Kruskal algorithm. In the next lecture we will discuss both the algorithms, how can we use them to find the minimum cost spanning tree.